Hello everyone, I'm Mr. Furlong, and today we're going to be talking about codominance. In the previous video, we looked at something called incomplete dominance, where if you get two dominant alleles together, there's a blending of the traits. Another example is codominance. This is where you bring two dominant alleles together, but instead of there being a blending of the traits, both traits are fully expressed. Let me give you an example of this. In chickens, the gene for black feather color and the gene for white feather color are codominant. So when you put these two together, you have a chicken that has both black and white feathers. It's not gray. They're not blending with one another. All right, these are referred to as an erminette chicken. So let's do a cross. We're going to use the capital letter B to represent the black allele and the capital letter W to represent the white allele. And it says that in a cross of a black feathered chicken and a white feathered chicken, the resulting offspring will have both black and white feathers. And we can certainly show that with our cross. So this would be the original parents. We separate the two alleles, put one set above each column, one in front of each row, and we can see that in fact all of them would have black and white feathers. So again, these are called erminette chickens, and so let's do a cross here. It says to cross two of these erminette chickens, what are the phenotypic and genotypic ratios? So this would be a cross of a BW with a BW, so we do our Punnett square, we separate the two alleles, and we have a black feathered chicken, one with black and white feathers, another one with black and white feathers, and one with white feathers. So the phenotypic ratio in this case is going to be 1 black to 2 erminettes, black and white, to 1 white. So here we have 3 numbers in our ratio. The genotypic ratio is 1 BB, 2 BW, 1 WW. So notice our phenotypic and genotypic ratios are the same. And a little hint, anytime you do one of these codominant traits, they're always going to have the same phenotypic ratio. So let's look at another example. This is a very popular one with codominance. It's also known as a multiple allele trait because there are several possible alleles for a single trait, but an organism can only get 2 of these. So an example of this is blood type. There's 3 different alleles for blood type. There's the A allele, the B allele, and the O allele. The A and the B are both dominant, whereas the O is recessive. And so if the A and the B get together, both the A and the B proteins are going to be made, and hence a person has type AB blood. So there's 4 possible phenotypes of blood: type A, type B, type O, and type AB. Let's fill this chart out and look at what the possible genotypes are. So for instance, if a person is type A, they could be homozygous dominant for type A, or they could be heterozygous. They could have the A and the O allele. For a person who is type B, they could be homozygous dominant, or they could be heterozygous. Right? They could have BO. If they are type O, we know that they are homozygous recessive. And if they're type AB, here's where the codominance comes in. They have both the A and the B allele, so we know exactly what their genotype is. So let's do a couple examples of some blood typing crosses. So it says that a married couple has a child. The father is type A and the mother is type B. What is the chance of having a type O child? So again, dad is A, mom is B. They're both heterozygous, which would be 2 very common genotypes. So we do our Punnett square, and we figure out the chance of having a type O child. And we can see that only one of them is showing type O, so that would be a 25% chance. And so since even though dad is A and mom is B, they could have a type O child. Let's look at another one. Mother has twins. The mom is type A, baby 1 has type B, and baby 2 has type AB. What are the genotypes of the mother and the father? So this is an interesting one. All right, so we know a couple of things. For instance, we know that mom is A, and let's just assume that she's AO right now. She would have to be because she has a child who is type B. We don't know what dad is right now, but we do know that baby 1 is type B, which would have to be an O since mom is AO, and then baby 2 is type AB. So a couple things. We know that the A came from mom. That means the B has to come from dad. Now, what we don't know is dad BB or is he BO? And so we can do a simple cross here. Let's just assume that mom is AO, and let's do this one. We'll do dad as being homozygous dominant. Otherwise, it's the same cross as the last time. Can we get two children, one that's AB and one that's type B? And right away we can see that yes. And in fact, there's a 50% chance of each one of these. So we could probably say dad is probably homozygous dominant for type B. So you're going to go ahead and do some practicing with codominant traits. If you have any questions, please feel free to ask and I'll be there to help.